Hello and welcome to Tribe Topper. In this video, you are going to learn some energy problems that are based on the applications of law of conservation of energy. So here is our first problem. A ball of mass 0.35 kilograms is thrown vertically upwards at a speed of 8 meters per second. So let's first of all write down what is given to us till here. The mass of the ball is given, that is 0.35 kilograms, and vertically thrown upwards with an initial speed of, or you can put it as V only here, that will be 8 meters per second. Now, calculate the initial kinetic energy. What do we need to calculate the initial kinetic energy? Mass and velocity. So, for the part A, the initial kinetic energy is simply half mv square, and we plug in the values, that is half times 0.35 times 8 square, and solving this we get 11.2 joules. So the first part is done. Now they say, what is the maximum gravitational potential energy? What is the thought that comes into mind is, we don't know what is the height to which they have raised. So how can I find the maximum gravitational potential energy? So just remember the concept of conservation of energy. I have told this in my previous videos. The gravitational potential energy at the top is going to be equal to the kinetic energy at the bottom. So the maximum gravitational potential energy will be equal to the KE max with what we started. So that means you don't even need to calculate. Therefore, your gravitational potential energy, the maximum energy, is also 11.2 joules, which was the initial kinetic energy by law of conservation of energy. Now that we know the gravitational potential energy, so they ask the maximum height reached. Not a problem, we can find it out. Because we know the gravitational potential energy, what's the formula? That's mg times h, and we have the value. So m times g times h is equal to 11.2. Mass is 0.35. G is 10 times h is 11.2. Therefore, what will be the height reached? Simply 11.2 over 0.35 into 10 is 3.5. So dividing these two, we get the height as 3.3 meters. So guys, you can see here, all I did is applying the law of conservation of energy and equating the kinetic energy with gravitational potential energy and equating the gravitational potential energy with its formula. Let's have one more problem here. So our next problem talks about a pendulum bob. So here a bob is released from rest 0.15 meters above its rest position. So they have shown you here that this is the extreme position and this extreme position is 0.15 meters above the rest position. And they want us to find the speed as it passes through the rest position. So what do we know here about the pendulum? You only need to know that potential energy, the potential energy exists at the extreme positions and the kinetic energy exists at the mean position. And you have maximum potential energy at the extreme position where kinetic energy is 0 here, right? And your maximum kinetic energy exists at the rest position, and at this point your gravitational potential energy is 0. So what are we going to do? We'll equate again, because whatever was the gravitational potential energy, the maximum gravitational potential energy at the extreme position is the one which is going to be converted into the maximum kinetic energy at the rest position. So all we have to do is we'll equate, that's mgh is equal to half mv square. Since we want to find the speed as it passes through the rest position, so using this, your m and m cancels out. This gives you v square is 2gh. Therefore, v is square root of 2 times g is 10 times h they have given us. The initial height was 0.15 meters. And solving this, we get 1.7 meters per second. So here we knew the pendulum's height, that is for the extreme position. Again, we equated them with the kinetic energy at the rest position will be equal to the gravitational potential energy at the extreme positions. Just equate them and you're done. So I hope these two problems were helpful, and almost all the problems you'll be solving like this. So in the next video session, we are going to talk about elastic potential energy and another problems which are related to the law of conservation of energy again, but you'll be converting from elastic potential energy as well. So that's all for this video. Thank you.